Lesson 2 in Module 1 is multiplying and dividing monomials. So you want to watch the Explore. We're not going to do that in here. A monomial, another vocab word, monomial, is a number, a variable, or a product. Guys, some of you don't know what that means. It means multiplication of a number and one or more variables. Okay? So you could have it 6y squared, 6 and y squared are both monomials, and they are a product. And because it's a product, it becomes 1. And by the way, this means 1. Why did I just write it in Spanish? Okay. This right here is not, because it has a plus sign in between it, it is not a monomial. It's actually a binomial. Okay, when addition or subtraction signs separate an algebraic expression into parts, it is called a term. Okay? So this is one term, this is another term. Okay? It has two terms. So which one of these are monomials and which one are not monomials? So first things I would look at, do they have a plus sign or a minus sign? This has a minus sign, so that goes here. This has a plus sign, so this goes here. This is multiplication, so it goes there. Multiplication, well, it's just one number. It's just one variable, so that goes there. Okay, next. So the first thing we want to simplify 4 squared and 4 to the third. And in order to do that, first you write 4 squared as factors, write 4 to the third as factors, and then you look and see how many total of the exact same factor you have. You have 5 of them. And since you have 5 of them, that means you have 4 to the 5th. When I just said, let's look how many we have, didn't we just add them up? We added these 2 and these 3 to get 5. This is what is called the product of powers property. And what that means is that you're going to, if they have the same base, that you're going to add their exponents. Okay? So I have the same base, I'm going to add their exponents. 7. Okay, so let's look here. We have the exact same base. Now, you have to remember that there's an invisible 1 there because there is 1 5. So you add that 5 to the 5th. Or you multiply it out and you get 3,125. So here we do it here. I have 1, 2, 3, 4, 5. I have 1, 2, 3. So that would get me 8, but you could have just added the exponents because the bases are exactly the same. We just add their exponents and we still get 4 to the 8th power. Here we go. My bases are exactly the same. Because my bases are the same, I can add their exponents. Are my bases the same down here? Yes, they are, so I write it down. Then I add the exponents, so I have x to the 10th. Down here, now you have to make sure that you have the exact same bases. If you don't have the same bases, then you can't add the exponents. So I look at this. This is a coefficient. This is a coefficient. So my coefficients, I'm going to write together because those are going to be multiplied. They're not the same base, so they don't add exponents. They just get multiplied. So negative 3 times 4 gets me negative 12. Then I'm going to take the ones that have the same base right here and I'm going to put them together. They're the same base, so that means I can add their exponents. So I have negative 12x to the 7th. Okay, let's come down here. I have negative 2 and I have 3. Those are coefficients. They are not the same bases. Then I have a, and there's only one of them there, so remember there's a 1, and I have a to the 4th. I have this one and I have this one. Okay, the coefficients are going to be multiplied together. These have the same bases, so I would add their exponents. So my answer would come out to be negative 6a to the 5th. And it's right there. Okay, so now let's look at the quotient. So I'm going to write out I have 3 to the 6th power over 3 squared. First of all, are there more 3's on top or on bottom? There are more 3's on top. So I write out my 6 3's up here. I write out my 2 3's here, and I cancel out. When I do that, I get 4 3's on top and 1 on bottom, so that is 3 to the 4th power. Well, if I do it with the property, all I'm doing is subtracting the exponents. As long as I have the same base, all I do is subtract the exponents. That is called the quotient of powers property. So what it says is if I have the same base, I can subtract the exponents. I have the same base, so I subtract the exponents. So we're going to come down here. Are these the same base? They sure are, so I write it down. I subtract the exponents, and I get x to the 6th. There were more x's on top than there were on bottom. So right here, do I have the same bases? I sure do. It's division or a quotient, so I subtract, and I get z to the 8th power. Okay. Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is 2 to the 7th miles long. How many times larger is Hawaii's shoreline than New Hampshire's? So I would put 2 to the 10th on top and 2 to the 7th on bottom. They have the same base, so I'm going to subtract my exponents, and I get 2 to the 3rd, and that would be 8. So they're 8 times longer. So Hawaii's shoreline is about 8 times longer than New Hampshire's. Okay, so now we're going to check this and make sure we know what we're doing. So it says the table shows a seating capacity of 2 different facilities. About how many times greater is the capacity of Madison Square Garden, this one, so 3 to the 9th, than the typical movie theater, so over 3 to the 5th. So now I'm going to divide this out, and when I divide that out, they have the same base, so I subtract the exponents, and I would get 3 to the 4th power. Oh, well, that would be 81, so 81 times. Okay, so next, now you have a whole bunch of them. This is when you have to be careful of having the same bases. So if I look at this, they were really nice and they lined up each one of these. So it would be good to either write them separately, like you could have done 2 to the 5th over 2 squared without the parentheses. It doesn't matter. But make sure you're keeping the ones that are alike together. So 2 to the 5 minus 2 would get 2 to the third, 3 to the first, and 5 to the first. So that gets me 8 times 3 times 5. And let's see, 24 times 5 is going to get me 120. And there we have it. Okay, so let's check your understanding. So I have 2 squared over 2, 3 to the third over 3, 4 to the fifth over 4 to the fourth. Remember, this has an invisible 1 and an invisible 1. So 2 to the 2 minus 1 times 3 to the 3 minus 1 times 4 to the 5 minus 4. So this would get me 2 to the first, 3 to the second, and 4 to the first. So this is 2 times 9 times 4. So 18 times 4 would get me, we didn't have to multiply it out. We just wanted this right here. So that would give me this one right here. Nope, it would not. Sorry about that. It'd give me that one. Okay. So now we have a coefficient in front. Again, we separate the coefficients from the variables. This, you're going to flat out divide this. You're just going to divide the numbers. They do not have the same base, so you can't do anything other than just divide it. Now this, they have the same base, so that's when you subtract the exponents. So I would get 6w to the fourth. So let's look at this. My coefficients are going to be separate from my variables. So I divide this and I get 4. Over here they have the same base, so I subtract their exponents. So I get 4k to the fourth. The processing speed of a certain computer is 10 to the 12th instructions per second. A second computer has a processing speed that is 10 to the 5th times as fast as the first computer. The third computer has a processing speed of 10 to the 15th instructions per second. Which computer has the fastest processing? Okay. So first we have to look at each one of these and make sure that we understand what it's talking about. So, let's see. Which one has the biggest? Well, do you understand what it's actually asking? So let's see. We have the first computer is 10 to the 12th. The second computer is 10 to the 5th. Now be careful with this one. It says times faster than the first. And then the third is 10 to the 15th. So some of you are going to say, oh, it's the third one. Well, if we were just looking at it like this, I would agree with you. But this says this right here. 10 to the 5th times faster. So it's 10 to the 5th times faster than the first one. So I need to multiply this out. So the bases are the same, so I add the exponents. I get 10 to the 17th. Look at that, that's bigger than all of those. So that means the second computer actually has the fastest speed.